Number 13, they're asking us to find the area between these two curves, and what we're going to do is we're going to go ahead and use a calculator. So we're going to graph it. So I'm going to graph x cubed minus 2x squared plus 10 in y1 and 3x squared plus 4x minus 10 in y2. So if I graph it, it looks something like this. So to find the area, we're going to go ahead and draw a vertical rectangle. The reason it's vertical because notice that it doesn't matter where I draw it, the top minus the bottom is the same. So I'm going to find the area of this rectangle, which is going to be the same as finding the area of the whole thing. So this is going to be a small change in x. So it's going to be the top minus the bottom. That would give me the length. Okay, so remember that. This represents the length of the rectangle, and this represents the base, which is a small change in height. So this is the area of one of the rectangles. So to find the sum of all of them, we have to take the antiderivative, and we're going to go from -2 to 2. So again, we're using my calculator for this. So I'm just going to go ahead and put this on my calculator, and I get 160 over 3. Number 14 is asking us to find the area between the two curves. So we're not going to use our calculator because you need to know how to graph e to the x. So notice that this is a gross. So what that means is it's going to start low and go high. E to the 2x is actually going to be a little bit more steeper. So this is graph that you need to know more or less how to sketch. So to find the area, we're going to go ahead and draw a rectangle, find the length of the rectangle. So the length is the top minus the bottom times dx. So e to the 2x minus e to the x is the length, dx is the base. We're going from 0 to 1. So we take the antiderivative. The antiderivative of e to the 2x is e to the 2x divided by the derivative of u. Okay, so usually when we take the derivative, we're multiplying, because we're taking the antiderivative, we need to divide. So if we substitute 1 and 0, remember that if you substitute 1 minus substitute 0, and we simplify, we get 1/2 e squared minus e plus 1/2. For number 15, we want to find the antiderivative of tangent squared. To find the antiderivative of tangent squared, we have to use one of the Pythagorean identities. And the Pythagorean identity says that tangent squared of x is equal to secant squared of x minus 1. And yes, we need to memorize this. So if we substitute this, notice that it's not x, it's 4x. So what we're going to do is we're going to have secant squared of 4x minus 1. The reason we use this Pythagorean identity, because now we can find the antiderivative of secant squared. The antiderivative of secant squared is tangent. And don't forget that you have to divide by the derivative of the inside, since we're taking the antiderivative instead of taking the derivative. So if we take the derivative, we multiply. We take the antiderivative, we divide. The antiderivative of 1 is x, and then don't forget your plus c.